Hello everyone. In this lecture, I am going to introduce you about character data type, another important data type, and it is a type of integer data type, integral data type, sorry, and integral type is basically integer type and character type. Now, this character data type is usually basically consisting of char data type, but with the requirement for the support for multilingual characters, the new data type, that is wchar_t, was introduced with C++11. Now, char data type, as you know, is used to store character literals, and these character literals we have already discussed. So, single character literal, which is written as in inverted commas like this, is stored in a variable this, and here the variable data type is char. So during compilation, when this particular statement is compiled, this character literal gets translated to the ASCII code, and memory space, that is in the memory space allocated to this variable, that is of char type, the ASCII value of that particular character literal gets stored. So in order to but when we print this particular character literal, we get the value y, that is a character instead of the ASCII value. So if you have to print that particular ASCII value, you have to typecast this particular character literal variable in which it is stored by integer data type. Now this particular character literal requires 1 byte of memory, and all character literals are initialized to /0, which is printed with a null, which is printed with an empty space. If you try to print this particular character by not initializing it with any value, then it will get printed with something like blank space or something, if you can try. So next is wchar literal, wchar_d data type. Now we have discussed that in order to declare wchar type data type literals, we prefix that particular literal with the letter L. Now these particular character literals are specifically used to store Unicode characters or ASCII, non-ASCII characters. Now here my char is representing a variable which is of wchar_t type, and which is basically a new type, and it is usually of 4 bytes, but in some cases the compiler indicates it to be of 2 bytes, and typically it is used to support Unicode character. So everything is similar here, that the character represented will be converted to the Unicode, and whatever memory is allocated to it so will be stored as a Unicode character. But when you try to print, it will try to give you the Unicode equivalent, and it is must that your compilers must support Unicode. In that case, if it is not supporting, then this particular extended character set value will not be there. So it is ensured that otherwise it will print the integer value, that is for sure. So you will check now how these values get printed. Now in this program, I'm going to show how character variables are assigned character literals. So you can see I've discussed this program earlier also, and in this program I will be discussing how character literals are assigned to character variables. Now in this particular, I have assigned a character literal A, and its ASCII value is 97. If you over your mouse, you can see over here, and this is assigned to a character variable ch1, and it is of char data type. Now similarly, you can also assign the integer value for this 97 directly to it, or the hexadecimal equivalent or octal equivalent also. And for wchar_t characters, because it is used to support Unicode characters, non-ASCII characters, when you are working with multilingual languages, so in that case you can write this for the same. And now you can check that if you print this character, you'll get the value of the character literal stored in this particular, although internally it is stored as a ASCII value, and size of this will be returning 1, and int is the integer equivalent by converting it to integer, that is a ASCII value of this number. So let's see, if you save and run this program, so you can see here we are getting A, we are following the size 1 and 97. And similarly, if you change it to contain this wchar, for wchar you can see over here, I save it and I run it. So for wchar it is giving me that this is equivalent to 160, although it is not printing the character over here. So I can no doubt write wcount and include the header file also. If some cases it works, but it depends upon the compiler. So I need to save it and run it. So it is printing some character, uh, but depends upon the compiler to compiler whether this value will be there or not. So size is 2 over here, and this is the value that is the Unicode equivalent of that particular thing. So thus your compiler has to support. So if you are working with character variables, then you have char data type and you have to assign these values in such a manner. Okay.